Of course, not every Pythagorean theorem question has us finding the longest side. Here we have a Pythagorean theorem question where we already know the longest side. So we know that if we made a square off of this short side and a square off of this short side, and I know those aren't really perfect squares, but let's just pretend they are, they would add together to give us the big square. Now in this case, we already know how big the big square is. It's the small one of the two small squares we're interested in. So when we set this up, we're not going to be adding, because you don't add two numbers to get a smaller number. So we must be subtracting. In this case, what we're going to say is the big square, which is 13.7. If we take away from it the yellow bit here, the 9.8 squared, all we're left with is the green bits. And I'm going to call the side we don't know x. So if we take the big one, the big square, and we take away one of the smaller squares, all that would be left is the second small square. Well, with that in mind, we can do this. Or at least we can try. So 13.7 squared minus 9.8 squared. I'm just doing that in my calculator. When I do that, I get 91.65. Now again, that's not the answer to the question. What that tells me is that this square has an area of 91.65 meters squared. But I want to know just how long the side x is. I don't want to know how big this square is. I want to know the side x. So I have to unsquare this thing. And of course, the mathematical way we unsquare something is to take the square root. So the side length x will just be the square root of 91.65 square meters. And when we do that, we get to one decimal place, it comes up to 9.5734, blah, blah, blah. But we would call that 9.6 meters. There we go. So we would come onto the graph here now, and I could say this is 9.6 meters, if the others are 9.8 and 13.7.